Okay, I think we're good. Here we go. Page what? 4? Does that sound right? Nope, nope, not that way. This page. Okay, here we go. Anybody want to read the story? It's a quick paragraph on what we're going to do.
Zhao Bridge in China, the oldest known bridge dating to 605 AD. You can model the support arc with the function f of x equals negative 0.0010.
Just say the equation. Start reading here.
Where x and y are measured in feet. How high is the arch above its supports? How long is the section of bridge above the arch?
How high is the arch above its supports, and how long is the section of bridge above the arch? Okay, so it's a bridge, right, guys? Okay, there's an arch here, something like that. So if I were you, I'd just kind of start with, this is what this bridge looks like. Now, to me, the bridge, there's a road up here, is my guess. The question they have for you is, how high is the arch above its supports? The supports are like right here. I mean, this is what's supporting the arch above the road. Okay, so how high is it? Well, above the supports, so I'll put that. So there's the support here, there's the support here, okay? How high is it above the support? So where would the highest point on this problem be? Vertex. It's right on top. It's right there. So guys, if you want to know how much higher that point is compared to this, you need to know the vertex. So somehow you have to get the vertex off this problem. And there is the equation that Brady was trying to read to you until I said, quit reading it. It's not worth it. Look how long it is. But you guys all have the capability, because you were here on Wednesday last week, to get the vertex, right?
Yeah.
Do it. Go get it right now. I'll give you about, let me give you 1 minute to get the vertex. You want your calculator, by the way. This is nasty. This is not a nice problem. Sean, are you done? No? Okay, you got an answer yet?
No.
No? Right? All I'm looking for is the x value. I don't care about the y, not yet. Amber, you got an answer?
No, not yet.
Okay.
60.9.
Say again.
60.9.
60.999, isn't it 999?
Yeah.
Yeah, which is roughly what?
61.
Can we just round and just say about 61? Okay, it's not quite 61, but we'll call it 61. Right? And you know it's going to be a positive because a negative divided by a negative is a positive, right? Okay. Okay. Guys, is that the height of the bridge? Is 61 the answer? No, that's the x value. That's moving this way. Move 61 this way. Up how high? That's the y value. Okay, now you gotta do what? Plug the 61 in, right? So plug this 61 into your equation here. Here. Be careful, period 4 struggled with this. About 6 of them got it right. That's about all.
I got negative 3.8.
Yeah.
Negative 3.
1.8.
First of all, I think it's positive. Okay, are you doing this? Negative 0.001075 times 61 squared, right? Plus 0.131148 times 61. It should come out positive. She's saying, I'm always saying it's negative 3.8. It's not negative.
It's still negative.
Yeah, that's what I know. I keep doing this.
You still get negative? That is not what period 4 got.
I got positive 3.9.
3.9 positive.
Yep.
And that's what you should get. And it's, is it 3.9? Is there more nines?
Yeah,
Okay,
it was like,
What does it say?
it was like 8.
So it's 3.999 like that.
Yeah,
Okay, can we round that number to
4.
4? So you should get 61 comma 4, and these are approximations. We're getting really close to the integer. And now you got to think this way. 61 4. How did we get to 61 4? You're gonna. First of all, the number 4 would be something. Like if you think of it as, here's your x-axis, here's your y-axis, right? Okay, if you look at this as your y-axis right here, as you move from this point, 61 this way, up what?
4.
4. Okay, so how high is the arch above its supports? What would you put? 61 or 4?
4.
Yeah, I mean it's up 4 from this support right here. So you'd say, I hope 4 feet. Right? How long is the section of bridge above the arch? Well, if you go above the arch, I mean this is above the arch. Here's where the arch starts. It goes up, 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 down, down, down. Well, the piece of the road up here is from there to there. So how far is this? How much? 122 because you did what?
61 times 2.
Yeah, so basically you said from here to here, that has to be 61. Going right through the vertex, from the vertex to here, has to be another 61. So how long is the, let me read that again. How long is the section of bridge above the arch? So this would be 61, 61, that'd be 120. 122, sorry. This makes 61, this makes 61, and there's your 122. You okay with that?
Yeah.
Okay, above the arch. Here's the arch. The section of bridge from there to there. Okay, 61, 61. And you know that it has to be 61, 61 because it's symmetrical. Okay? Questions? No hands. Move on. Okay. Next problem is very much the same thing. It's just a different story. Okay, here we go. Marnie throws a softball straight up into the air. The ball leaves her hand when it's exactly 5 feet from the ground. So she lets go of it. right here. And up it goes. The height h of the ball in feet can be written as a function of time in seconds as h equals this equation. H is the height. What's t again? T is what? Time. Time measured in what? Seconds. Okay. What is the maximum height the ball ever reaches? What's the highest it's ever going to go? Marnie catches the ball 5 feet from the ground. How long was the ball in the air? Let me just draw you a quick picture. Marnie throws the ball. Up, up, up. And down, down, down. Okay, here's the ground. There's the ball. Now remember this. This parabola is measured over time. T stands for seconds. So I don't know how long it takes. I have no idea how long it takes the ball to go up, reach its peak, and hit the ground. I have no idea. But this would be the picture, right? So here's your time versus what? Your height. Time versus height. Time is measured in seconds. I don't know. Is this measured in feet?
Mm-hmm.
Yeah, feet. Okay. So what is the maximum height of the ball? What point do you think you have to find? The vertex. Go find it. Go find the vertex. Opposite of B, negative 40. 2 times A, 2 times negative 16. What's the answer?
32.
How much? Negative
Oh, wait.
32? No. Oh, I think you're telling me negative 32 here.
Yeah.
Oh, I meant the final answer is,
5,
what is it?
5, 4.
5?
5 fourths.
5, 4.
5 fourths. Okay. 5 fourths is 1.25. Now remember what this stood for? This is T, comma, H. This is time, comma, height. So what does that stand for, that 1.25? Time. That's time. So basically, how long does it take? How long does it take to get to that maximum height? 1.25 seconds right here. Let's call this 1.25 seconds. Is that the answer, by the way? What is the maximum height? Did we get it?
No.
No, we don't have the maximum height. We have the time it took to get to the maximum height. Put that back in, exactly. Plug it in.
30.
30 even.
What do you do with that square though? I don't know how
Okay, tell me how this looks again. Oh, negative 16, right? 1.25 squared like that. Plus 40 times what? 1.25 plus 5. This is what I'm hearing everybody tell me. Right? Okay, what's the answer? What is the maximum height? 1.25 seconds, up how high? 30 feet. So guys, if you think of it like this is 30 on the y-axis right here. That's 30. So the answer is 30 feet. Okay, good. Okay. Nobody's even looking like I don't get it. Nobody's shaking their head like or rolling their eyes. We're good?
Yeah.
Okay. Marnie catches the ball 5 feet from the ground. How long was the ball in the air? Now here's the deal. She's not doing this. She's not running over here to catch it because she threw it which way? Which way did she throw it?
That way. Forward up.
Straight up. It said straight up. So she throws it, she stands here, she catches a 5. Why is the parabola going this way? Because it's the height versus what?
Time.
Time. All it is time goes by. As time goes by, the x-axis moves this way. The height keeps changing as the time goes. Okay? So she does catch it at 5 feet, but she throws it at 5 feet, right? So guys, look at this. She catches it right there.
So it'd be 20,
So what is it?
25.
How long was the ball in the air?
Oh, never mind.
How long was it? Hey, from her hand, when she let go of it, up to here, how long did that take? 1.25 seconds. But then it took how long to get down to 5 feet again?
1.25.
Okay, so altogether, how long was it in the air? 2.5 seconds. Part B. Do you guys notice how similar this was to the last one? Remember the last one was 61 plus 61? Well, this one's 1.25 plus 1.25. It's the same thing. So the story problems are pretty much all set up like these, right? Can I move on? Yeah? Yep. Okay, if you want to know where period 4 got really, really lost, this is it. Okay, listen closely and slow me down and say, wait a minute, stop, stop, stop. I don't get what you just did. Alright? Because this is kind of a weird problem. Alright? Write a quadratic function to represent the areas of all rectangles with a perimeter of 36 feet. Graph the function and describe the rectangle that has the largest area. Okay, I gotta read something here. It says, write an equation that represents the area of a rectangle with perimeter 36 feet. Let x be the width, let y be the length. Represents. Oh, that's why it's messed up. Okay, sorry. I read something in period 4 and it didn't make sense. Okay, here's what it says. Write an equation that represents, and I just want you to do this. Cross that out through here. And that's probably good. Okay, cross that out. Write an equation that represents a rectangle with a perimeter of 36 feet. Okay, really, really important that you do that, because otherwise that problem doesn't make much sense. Okay, so write an equation that represents a rectangle with a perimeter of 36 feet. Let x be the width, y be the length. You might want to do this. Maybe go like that. There's your rectangle. Width, x, length, y. And the perimeter is? What's the perimeter here? 36 feet. By the way, what's perimeter? What does the perimeter mean? Distance around the outside edge. So just keep adding edge, 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 edge. Add all the edges up. So what would be an equation? X plus y. X plus y equals 36. Agreed?
No, 2x plus 2y.
Now I want 2x.
Yeah.
Okay. Because this side is x, and that side is x, so that's 2x. This side is y. This side is y. 1x, 1x. 2x plus 2y equals 36. There it is. Okay, there's your perimeter formula. You probably wrote it 100 times last year in geometry. Right? Not really 100 times? Okay, 97 times you wrote it last year. Twice. Solve. Ready? Solve your equation for what letter? Y. Go. Do it. This shouldn't take you very long. Solve for Y. Just I'm kind of walking you step by step through this problem. I'll show you why you're doing this in just a little bit. Was that your first step? Solve for Y, subtract the 2x. What's the next step?
Divide by 2.
Divide by 2, and 2, and 2, and you get Y equals what?
18, negative x.
18 minus
Can I say?
x, or negative x plus 18, whatever you want to say. Is everybody okay with that? Okay. You know what? You know what you're trying to. Here's what you're saying. Y is the length. The length is equal to 18 take away the width. That's what you're saying. The length equals 18 take away the width. That's all you're saying. Now, here's what you're really trying to do. Because if you go back up to this problem up here, it says, describe the rectangle that has the largest what?
Area.
Area. How can I take a rectangle with perimeter of 36 and maximize the area? How do I do that? Well, step 3 says, well, why don't you start by writing a function for the area of a rectangle? So what does area equal of a rectangle? Say again. Base times height. But I don't have base, I don't have height. I have what?
X and y.
I have width and length. So just say what? Area equals what? X, which is the width, times y, which is the length. Would you agree? Okay. Now, here's the deal. They want you to write this equation for the area of a rectangle, but now, how many letters do I have? How many variables? 3 variables. I don't want 3 variables. So what you're going to do is use the substitution method. Remember this? This would be considered home. What does y equal, guys?
18 minus x.
18 minus x. So can't I just say the area of my rectangle will be x times y. What's y? 18 minus x. Right? What's the area of my rectangle going to equal? X times 18?
18x.
18x minus x times x?
X squared.
Yep. There you go. This is your equation for the area of your rectangle that has a perimeter of 36. Okay. Step 4 says do what to it? Go graph it. Okay. You want me to graph that? I'll graph it. Here we go. Area equals 18x minus x squared. I need the vertex. How do you get the vertex out of this? Negative b over 2a. Which one's b? 18. Negative 18 divided by 2 times a. What's a? Negative 1. Which would be 18. Sorry, negative 18 divided by, which is 9. 9 comma something. Put the 9 back into your equation. What's the area going to be? 18 times 9 minus 9 squared. 81. Good? By the way, that's called your vertex, right? Okay. So 981 is your vertex. They want you to graph it. Here's the deal. It's kind of hard to graph this. If I were you, I would just get some really, really simple points. Like, what's a really simple point on this equation? What would be a really simple number to plug in for x?
0.
0. What if you plugged in 0? So I'm just getting another point. 0 goes in. What's 18 times 0 minus 0 squared?
0.
Right? 0, 0. Now remember, this is the vertex. 0, 0 would be like right here. How do you graph 9, 81? What do you want me to go by? You can go by what?
Ones on the x's.
If I go by ones, watch. 1, 2, 3, 4, 5, 6, 7, 8, 9. And the vertex will be up here. So it will go like this. And this, I'll fall off my graph.
Count by nine.
I think if I were you, because this is your vertex, you kind of want your vertex to land somewhere in here. I would go by 2s. So I'd go 0, 2, 4, 6, 8, 10, 12. Okay, so we're at 9, 81. Well, if you got to get to 81, go by, what do you want to go by? You want to go by 9s. Okay. 9, 18, 27, 36, 45, 54, 63, 72, 81. Perfect. 9, 81. There it is. You got there. And by the way, that's your vertex. So you do know your parabola goes like this. Right? Does anybody know where it lands?
Probably 18.
Yeah, it does, because this is 9. That would be another 9. So you'd be at 18, 14, 16. Here's 18, right about here. And there it lands. Okay? Right? Okay. Now here's what's really, really crucial, guys. You guys, in a story problem, you should label your x, you should label your y-axis. What did your x stand for? What
The
did,
width.
what?
Width.
Width, it's the width. You are measuring the width of your rectangle versus the what?
No. Length.
No, it's not height.
Length.
No, it's not length. Look at, hey, look. X is the width versus the
Oh, area.
area. Guys, this is area. This is the area of your rectangle versus the width. So guys, if you have a 9-foot width, you're gonna max out right here. You're gonna max out at 81 square feet. Does that make sense? Now, do you remember what the question said in the very beginning? Go up to the very, very beginning and it said, graph the function and describe the rectangle that has the largest area. What rectangle has the largest area? Right here. A 9 for width. What do you think the length has to be to get 81? 9 times what is going to give you 81? 9. You have a 9 by 9 rectangle. So keep going. What point on the graph has the coordinate that represents the largest area? The largest area is represented by the vertex. 9 for the width, 81 for the area. Okay? How can you find the coordinates of this point? What are the coordinates? Oh boy. Can we just say this? See my work above? Because we did it, didn't we? Number 7, describe the rectangle that has the largest area. And what is its area? Describe the rectangle. What would it have to be if the area is 81? Guys, what's the dimensions? We already know the width had to be 9, right? It's gotta be a 9 by 9, doesn't it? Yeah. So if you want to maximize the area of your rectangle, make a 9 by 9 rectangle, and you've got it. And by the way, a 9 by 9 is just a square, right? Good?
Very good.
You should be okay on everything except, is number 38 in your assignment?
Yes.
Okay, I'm not saying you can't do it, I'm saying I didn't do it. It's the next problem in your notes, I didn't do it. So here's the deal, you're gonna have to read it, try and make some sense of it, and see if you can get it yourself, okay? So 38 is gonna give you a little bit of trouble. All right. Who's got a calendar? I wanna look at your calendar. Okay, I wanna see what it is. Repeat. Looks like a lot of this is repeat from last week. 14, 18, 19. Okay, that's repeat. 26, repeat. 28, repeat. 32.
It's right
And then I didn't my phone case he's coming.
I'd be so scared to hear.
Some of this is just repeat from Wednesday. So, and then some of it's new, like we just talked about. You should be okay.
We have to do
This one?
the same problems we've already done.
The 6 or the 6S?
They were new, but it wasn't old.
Oh, yeah, it could be either. If it was road call,